So up until this point, you guys learned qualitatively about compounds, how to name them, how they join together to form compounds. What we're going to do now is we're going to talk about them quantitatively. So understanding just the number of molecules or atoms that exist in something that you can see. And it's going to be an extremely large number because molecules and atoms are extremely small. And so what we're going to have to do is we're going to have to create a value to represent the large number of atoms or molecules, since we can't actually count them ourselves. And so this brings up the concept of the mole. Now, the mole is a concept, it is a number. Just as if I say I have a case of cans, that means I have 24 cans. Or if I have a gross of pencils, it's 144 pencils. Or one you might be more familiar with, 12 eggs is a dozen. One mole represents a very specific number, and we're going to get to that in 1 second, but let's first work on one conversion problem. So if I tell you I have 50 nails, how do you figure out how many dozen nails that would be? Well, you can do that in your head, I'm sure. However, let's actually do the proper setup, just like what we did with conversion. So if I have 50 nails, I'm going to convert that into dozens. So I'm going to put nails on bottom and dozen up top. Now I know there are 12 nails in 1 dozen, and so what I'm going to do is I'm going to take 50 and I'm going to divide it by 12, and what I get is 4.167 dozen. Now I need to round to the correct number of significant figures. Okay, and so there's going to be one significant figure here because 50 is one sig fig, even though it is counted. So this is going to be 4 dozen. All right, not too crazy. Now let's understand the concept of the mole by comparing it to a dozen. So for example, while 1 dozen is 12, it represents a number, a mole represents 6.022 times 10 to the 23rd. That is Avogadro's number, 6.022 times 10 to the 23rd. That is 20 zeros after the 6022. Okay, so it is an extremely large number, and that makes sense because molecules and atoms are extremely small. Now, the question you should have in your mind now is, well, what are particles? Well, there are 3 different types of particles that we'll be working with. The first are formula units. So if you have an ionic compound which forms a crystal lattice structure, instead of identifying just one molecule, instead, because there are millions of those atoms combined in that crystal structure, we identify, for example, 1 sodium and 1 chloride. That is just one formula unit. So you're going to be using the term formula units when you're talking about ionic compounds. Now, if you have a molecular compound, meaning with covalent bonding, so for example, here is water, they will exist individually, not in that crystal structure that you see in ionic bonding. And so we're going to use the term molecules for those. And finally, if you simply just have individual atoms, you'll use the term atoms. So particles can either be formula units if you have an ionic compound, molecules if you're having covalent bonding, or atoms if you just have individual atoms. So for example, if I tell you I have 1 mole of carbon, how many and what particle do you have? Well, it's an atom, and I would have 6.022 times 10 to the 23rd atoms. If I tell you I have 1 mole of water, well, that has covalent bonding, so that would be 6.022 times 10 to the 23rd molecules. And finally, if I tell you I have 1 mole of sodium hydroxide, well, that's ionic bonding because you've got a metal and your non-metal. And therefore, that would be 6.022 times 10 to the 23rd formula units. So let's actually apply this. I'm going to convert between moles and those particles, whether it's atoms, molecules, or formula units. So if I'm given 2.12 moles of C3H8, and I'm asked for how many molecules I would have, remember, because that has covalent bonding because you have 2 nonmetals, I'm going to start with my given, which is 2.12. I'm going to crisscross swoosh, I'm going to put moles on bottom, and I'm going to put molecules up top. Nothing new here. The only new thing is that there are 6.022 times 10 to the 23rd molecules in 1 mole. And so what I'm going to do is I'm going to multiply. I get 1.2767 times 10 to the 24th molecules. Now I need to round to the correct number of significant figures. 2.12 has 3 significant figures, so I'm going to round this to 1.28 times 10 to the 24th molecules, and that's it. The only issue with all of this is I can't count moles, I can't count molecules, and so there's going to have to be something in the lab that I can actually measure. And what we can measure is mass. Now, the cool thing is that the average atomic mass that we've been using, for example, silver is 107.9 AMU, 107.9 grams of silver is in 1 mole. Okay? 12.01 grams of carbon is in 1 mole of carbon. And so this allows me to relate grams to moles. So now, instead of just looking at the very small unit of AMU, I can actually give it a unit that I can measure in the lab, a value large enough, which would be grams. Okay, so this is called the molar mass, meaning the mass in grams per mole of substance that you have. So if I were to ask you to find the molar mass of silver sulfide, the first thing I need to do is write the formula. And I told you guys, you need to learn this so that you can answer these questions. Silver has a +1 charge, sulfur has a 2- charge, and so when I cross my charges, because it's an ionic compound, I'm going to get Ag2S. Now, to find the molar mass of silver sulfide, what I'm going to do is I'm going to take the molar mass of silver, which is 107.9, and I'm going to multiply that by 2 because there are 2 silver atoms. And I'm going to add to that the molar mass of sulfur, which is 32.07. And what I get for my final answer, rounded to 2 decimal places, is 247.87. Now, the last thing that I need to do is put units. While, yes, the units would be AMU if I'm talking about average atomic mass, the other unit that I can use, which is going to be very useful now that I'm talking about moles, is that this is the mass per mole of that compound you have. So the units are going to be grams per mole.